Hello students, welcome to this Challenger series in physics for IIT Advanced Examination, and this is second question, and we have taken this question from Pathfinder, Challenge Your Understanding, Rotation chapter, question number 2. Let's read the question. You find a table of height h equals to 1 meter and a square top of side L equals to 1 meter. So you have a square tabletop and you have a table of height 1 meter. One leg of the table is slightly shorter than the other 3 legs by amount delta h equals to 1 centimeter. So you have 4 legs there, not you, the table has 4 legs. Out of that 3 legs are of 1 meter and 1 leg is slightly shorter, 1 centimeter less, maybe because of wear and tear or cut, whatever. When the shorter leg is touching the ground, so the table is not horizontal, it is tilted a little bit. So the shorter leg touches the ground, then the opposite leg would be lifted up, the top is slightly tilted, yes. To make the top horizontal, now we need to make it horizontal, you have to put a minimum mass m naught equals to 200 grams on the tabletop at the other opposite corner, just opposite corner to the shorter leg, okay. Find the mass capital M of the tabletop, we have to find the mass of the tabletop. Assume perfectly horizontal floor, no inclination there, and uniform tabletop. So the mass of the tabletop is uniform, so that center of mass of the tabletop is the center of the tabletop. And also the legs are very light. So that means entire mass of the table is nothing but mass of the tabletop. Okay, so that's a question they have asked. We are supposed to find that capital M. So whenever they give this kind of 3D diagrams, we will do projections like top view, you see, side view, front view. This is something that we do in engineering diagram. It's very common engineering drawing, we call them as. So first let's look at the top view. Imagine you are going in a helicopter and then start seeing from the top, and you see the top of the table which is square in shape, ABCD, length L. The diagonals are AC and BD intersecting at point O. So the total length of the diagonal is L root 2. So half of it will be L by root 2. A, O, OB, OC and OD, all of them are going to be L upon root 2. So this is the top view, you get the information in the plane there, horizontal plane. Now if you want to understand the legs here, we need to look at some other view. Imagine a line of sight which is AOC, and through that if you observe, whatever is the left of it will be D and the leg below it, and what is the right of it will be B and the leg below it. So imagine that D is having a shorter leg and B is having a bigger leg. That I am going to show the projection there, that is called side view projection here. So when you are seeing through, then you see A is in front of you, O and C will be behind you, and D will be left of you and B is on the right side. Below D the leg is assumed to be shorter one by delta H, and when that leg touches, the opposite, diametrically opposite will be B, which would be lifted up. So that is what we have. The separation between D and B is the diagonal L root 2. Okay, so that is another projection, we have it. Now the question is drawn here. So you can pause here, and if you want you can try to solve it. We need to find how much mass we need to place here at B, so that the leg below D will be just lifted up. That is the minimum that you want to apply it. So let me go with the solution. The first one is the simple concept of equilibrium. Whenever a block is there, let us say, and it is placed on a horizontal surface, so you will have one contact force, normal reaction, balancing mg, translational equilibrium. And also if you apply rotational equilibrium, talk about center of mass has to be 0 for rotational equilibrium. And whenever gravity is uniform, which is the usual case that we consider in this particular problems, so center of gravity coincides with center of mass. So center of mass, center of gravity we use interchangeably here. Now talk about center of mass or talk about center of gravity when you are calculating. Due to mg will be 0 because mg passes through it. Then due to n also should be 0, then only the net torque about center of mass will be 0. That means n has to pass through that center of gravity or center of mass. So if you take that n vertical line, it should pass through center of mass. The line of action of n should pass through center of mass or center of gravity. That is a simple concept, we have it. So this concept I want to apply here. Let us come to this particular diagram, bit enlarged, side view we are looking at. So right now D leg under D is touching, leg under A is touching, leg under C is also touching. C you can't see, it is in the big back side. B under leg, that leg is lifted up. So 3 contacts are there now. So now if I start adding the mass slowly at point B, gradually keep on increasing the mass, then what would happen is the normal reaction at D will be continuously decreasing. Normal reaction at D will be continuously decreasing, because torque about this point, if you consider, torque due to mg which is added at B will be increasing, because of that nd will decrease. So there will be a point where we have enough mass added here, there the leg below D is just about to be lifted up. So not lifting, still it is in rotational equilibrium and translational equilibrium, but about to be lifted up. When it is about to be lifted up, then normal reaction at D becomes 0. So that you know it, about to lose contact, break of the surface we call it as. Now at this moment the microscopic contacts are only at 2 places. One is at the leg under A and another is leg under C. C you cannot see it, it is on the other side. So NA and NC, they will be vertical, they will be in one single vertical plane. The effective contact force of NA and NC could also be written as 1N. This is what N I am writing here. This N equals to NA plus NC, and we take that in such a way that it produces the same torque, NA plus NC equal to N there. So this is what we have now. So overall there are 2 forces acting. I am reducing this entire thing into 2 forces. One is the net weight, effective center of gravity you can calculate, we have tabletop and particle, together net weight, and also you have net normal reaction. This normal reaction will be in this vertical plane. So if you use this concept here, this normal reaction, when you draw that vertical line, wherever it cuts the tabletop, and that is where the effective center of gravity will be present. So that G will be effective center of gravity of capital M and small m. Capital M will have center of mass at A, not A actually, it will be at O. You can't see O there, it is behind it. So at O you will have it center of mass capital M, and then B, at B you have small m. The separation between them will be L by root 2, and G is the center of gravity which will divide that line joining. So that is a concept, we have it. So once I have that concept right, we can go with the little bit of geometry. Let's go on with the geometry to understand that heights R1 I want to calculate. So this is A is the, not A, in fact behind A you have O, that is the center of the table where the capital M is present, and this is G. So OB, if you take that line, right, so that line will be divided there, that R1 I want to calculate. So for that I am using this geometry. The first one is, of course in physics generally geometry meaning right angle triangles and trigonometry, Pythagoras theorem, only very simple. First let us consider the triangle PQR, where at R you have 90 degrees. So opposite to 90 degrees, PQ is the hypotenuse, and QR is opposite side, which is delta H, you can calculate it, and PR is nothing but AD, because they are opposite sides in a rectangle equal, which is L by root 2. Not AD, it is OD actually. O you will not be able to see there, it is behind A there. So BD is the diagonal, the midpoint of BD would be O there, behind A. Okay, now if I write tan theta would be equal to QR divided by PR. QR is delta H, PR is L by root 2, you get that formula. So that is equation 1, we got tan theta from there. Once I have tan theta, now I use the tan theta in another triangle, and that is a triangle QAG. I want to find R1. So for that triangle, R1 is the opposite side. So I use tan theta equal to AG upon AQ, opposite side by adjacent side. AQ is nothing but length of the leg, height of the leg there, H. So from there I will get R1 by comparing 1 and 2. So R1 I got using simple geometry there. So that is a distance between G and O. Now to understand that R1, I will go in the top view now. Let us go with the 3D diagram now. This is O. So we were seeing through this line. This was the line of sight we have. That is why A was in front of it, but behind that you had O. Left of it you had D, and right of it you had B. So B was the Under B we had a leg which is lifted up. D was having a leg which is shorter there. So this is R1. This is R1. I want to calculate that R1. So that is OG. MG is OG is R1. R1 we have to calculate. So for that we have simple idea. Whenever 2 point masses are there with certain separation, let's say D equal to R1 plus R2, the center of mass or center of gravity, which are interchangeably used here, it divides the line joining in the inverse ratio of masses. So M1 R1 equals to M2 R2, and that is equal to reduced mass into the separation between them. So separation here between O and B is nothing but L by root 2. So use that formula, you will get capital M there. So capital M you get it by taking R1 this side. So but R1 is still there, but R1 we have calculated, na? You go back, you have R1 there. If I take that R1 and substitute here, you got the answer, capital M equal to small m into L square by 2 H delta H minus 1. So this is the question, derivation is completed. Of course I am not substituting the values, you can check it up and complete that part. So the difficulty here would be the projection of it, understanding that OB. So 3D visualization little bit. OB is what we are calculating, not AB in that projection, side view projection. Otherwise I think it's a simple question only, and I want you to see if you can get some other ideas of solving it. I really encourage you to give some suggestions, even if you are not solving it completely. Put your ideas, whatever is there, in the comment box. We can definitely have a good discussion about it, and after that I will take some more interesting questions. Let me conclude here. Wish you all the best.